to STEM with Seb. Today we will be building circuits 1 to 13 in the tronex set. So, first we shall be doing electronic circuit 1. Now, take note that before you do this, you do need to put the batteries in. I'm missing one, but this will not affect it. You only need 3 until you hit the 6-volt ones. So first, we're going to be starting with the simple rotor. Very easy, very simple. First, we go to 10 to 6. Now, if say you're 9 and 10, don't have all the batteries, just switch them around. Just like so. Everything is slottable except these. This can also be taken out. So we go from 10 to 6. So you can always use your fingers to measure out. So for this, I would say use a red. And just like that, it's connected. Next, because this isn't a closed circuit, we're going to go from 5 to 47. So another red. And then at 48 to 9 should be a green. You don't have to use the exact same wires I am using. I am just using the best ones because I want to avoid using any longer than necessary ones. Now, if your judgment is wrong, like say here, you can always grab the next size up or the next size down. So I got the green one wrong, so it is going up to a red. And now it's all connected. Next, because it's flying rotor, you put this on and you turn it on. Then, when you want it to stop and it to fly, turn it off. Now, when you want to dismantle, what I would normally do is I would grab the wires and just pull them because they're in springs. They don't get damaged. I've been doing it for years. Next, we're doing the colour filter. The exact same thing, but the only difference is you're putting this on instead. Now, you won't be able to see what this one's going to look like, so I'll edit in a video for you to see, and then you should see that it will start turning a little whiter near the edges. Always make sure you turn off the circuit before assembling. It also gets very loud. You may also see it going a fair bit brown. Next, we're going to do the electric top. Now, it's the same circuit, just the only difference is we're using this. Now I'm going to move the instructions out of the way because it's going to spin around here. Now hopefully you've assembled it right and it is working just as it should. Mine has recently had some issues, so it's not the best right now. Now it's not that hard to reassemble. All you've got to do is make sure the motor is in the right spot. Just like so. But mine is still not wanting to work. I will see you in a minute when it's all ready. Sadly, it is unrepairable, so we will not be doing electric top. If you want to know how to do it, I can still let you know. So, what you would do is you'd grab any of the wires that you may need, and then you do the same thing we did with the colour filter and the flying top. The only difference is you're connecting it up to these two respectively. So, with that terrible disappointment, we shall now be moving on to 4, the floating ball. Now I do not have the ball for this, so I'm just going to show you how to make it. I've actually found an improvisation. A little moon that weighs about the same as the ball and is about the same size. So what we're doing for this one, same as with all the other ones. We're connecting it to the same thing, just in a different area. So 10 to 2, can't do with white, 10 to 2, you can do with green. Keep in mind that these are only really simple circuits. Later on there are even sound amplification circuits. Anyway, after you've done 10 to 2, we're doing 1 to 47. So if you're lucky, a green, which we are. Now if you can't get it in properly with a green, you can always use a red, but I'm trying to use as short of a wire as I can. Anyway, now you go from 48 to 9, which, as we know from previous experiences, is always a red. And now, the ball is slowly rotating, you may not be able to see, but if it was the foam ball, it would be floating. But instead it's just moving. Now so far all the ones we have looked at use motors. This next one uses LEDs. So this time you're going to be using the large LED. the yellow one. So we are going 10 to 21. So, doesn't look like a white. This is barely not a white. This is a green. Now, next, we are connecting 20 to 48. I doubt we are so lucky to have it be a white. No, it is once again a green. Then it's 48 to 9, as usual. And then I'll send a picture of what it looks like when it's lit up in edit now. You'll notice that whenever you turn the light on, it will, whenever you flick the switch on, the light shines brightly. But if you disconnect the main switch, it will then go off. Now next, we're using the large green LED instead of the yellow one. This one I cannot do, as I need one more battery. Now, if you've got another battery, you can do this. So I'm going to be back in a second with another battery. Luckily for me, I have found another battery. So now I'll put it in. And now we can get started on the larger LED using the 6-volt power supply. For those of you keeping track on the numbers, we are now on number 6. Almost done the first page. So first, we've got 10. So this side to the other side, this one here. So this will be our longest wire, the blue one. So using your blue wire, you connect 10 to 75. After that, you connect 76 to 23. That would be a red. Alright, I have now done that. So now we go 22 to 48. This one will be a green. Now it's not a huge issue which way round you do the connections for the switch. As long as everything else is in the right connection, it will work. If not, it's just not going to work. Anyway, now 47 to 9. We may barely be able to get away with a green, and we do. Now when we turn it on, the large LED that's green should be quite bright. Now, if you want to, you can always change it over to the other one. Now visibly it doesn't look like much of a difference, but I can assure you there is. Here you can actually wire them up together. Now if you wire them up in series together, they will be the same brightness as if it was just one. But if you did them in parallel, they would be just as bright, because they'd only get half the current, but they'd get all the energy. So as long as they've got a lot of voltage, then it will work without a syringe. Next we shall move on to the second page, 7 to 13. Note that for 13 you will need a little bit of water, maybe even salt water. So first we're doing how to use the 6 volt power supply for other LEDs. Now this one's 20 to 21, the yellow large LED, but it's the same principle. 10 to 75. This time 76 to 66. Now this time we are using resistors. Resistors, well, as in the name, they resist the flow of the current. So imagine you've got the current, and then the resistance is pulling on the tube that the current is in. The voltage is what gets the current through, fighting the resistance. Anyway, after 66, we are doing 65 to 21. This one is either going to be a green or a red. I would advise using a red for this one. Now, if you want to know the sizes of each of these wires, you can just refer to one of the areas of the book where it shows all of the contents. The blue ones are the biggest, they're 40 centimetres. The red ones are 30 centimetres, the green ones are 20 centimetres, and the white ones are 10 centimetres. Apologies if I keep on moving this around. So after 21, we are going to do 20 to 48. Now after 48 we're doing 47 to 9 once again. Now a lot of things in this are really repetitive. Like for example, when we get up to the higher numbers, as things get more complex, we'll be using the variable resistors and the transistors. And whenever the variable resistor is, there's going to be the exact same transistor circuit, just with different components, like say LEDs, or my personal favourite, 201, which you'll see in a fair few episodes' time, the signal amplifier. We'll get more onto that when it comes. So now all the connections have been made, light it up. Now it will look like how it does beforehand because of the resistance. Now there is a resistance level where they just don't have any light. Which I'm trying to find right now. Okay, so 10 kilo ohms is the limit for 6 volts. Then you've got 5.1 kilo ohms. Then you've got 1 kilo ohms, which is the one we're using. And then you've got 100 ohms. Now ohms is the unit of resistance used. And its sign is the omega sign. So the Greek letter omega. Next, we're going to be doing function of the reed switch. That's what this is for. This has a magnet on one end and something that blocks light on the other, perfect for the light sensor. We'll be seeing the light sensor in the next episode. If you don't want to pull the wires out of where they go on the circuit, you don't have to. I just do it because it's really quick. This one, so it is 10 to 42, meaning we're using the colourful LEDs this time. And then we are doing 41 to 62. This is where we get to use one of our whites, because of how close they are. And then from 61, we go to 47, because it's always good to have several layers of protection from something accidentally turning on. Then we grab this, the green one, then we do the very repetitive connection 47 to 9. Now, here, when you turn on the switch, the LED won't actually turn on. But when you get this, now if you pay close attention when you're looking at it, you'll see that there's a metal bar in it that moves towards this, turning on the light. If you have any suggestions for future videos, leave a like and comment down below. Now we're doing demonstration of resistor and current. So this is where we get to start using more parallel things. Yep, it is the first in it that uses parallel circuits. Parallel circuits, instead of just having one path to go around, so battery to switch to motor back up to battery, it can go from, say, battery to switch, and from switch it can either go to one LED or a motor, then they can go back and join up. So this time there is more than one connection to one. There is one connection to another to another. This is really, really, really common in later circuits. So first we're doing 10 to 49. So 10 to, where is it? Here. So that is most definitely a red. So it goes 10 to 49, and then it also goes from there to 47. Now, next we're doing 48 to 65. So 48 to 65. If you're wondering why it's taking me a little longer, it's just because all the numbers are upside down so that you can see what I'm doing. And next we have 50 to 63. So, also green. And now both of these are going to conjoin back at one LED. So 66 to 64. Then to 21. The red. And now we're going to 20 to 9. Now this time, there are several directions for power to flow. We can either press down the switch here, which turns it on quite brightly, or we can turn on this switch, which turns it on quite dimly. You can combine both to make it really bright. But it only equals the same as if you just push down on the push switch. Now next we're going to a simple variable resistor. It's only simple because it's not having to control as much. Ones in the future are nowhere near this simple. They are mostly using transistors, so PNP, positive, negative, or NPN, negative, positive. So first, we are going to connect 10 to 47, as per usual. And now that we've done that, we're going to connect 48 to 63. And now we're going to have 64 to 38. Now, variable resistors also always include resistors. Hence why they're called variable resistors, because they can vary the resistance. Anyway, after 38 we're doing 39 to 21. Should be just a white. Now I've worked with variable resistors a fair bit when doing this because of my favourite one, 201, requiring a variable resistor as well as a speaker and a microphone. Next we are doing 20 to 9. Now if I turn it on, it's not got much resistance to it, so it's all bright. Now I'm going to very quickly put it onto that and see. You may be able to see the light getting lighter and darker. Yep, there it is. Now, the red dots say how much resistance you're putting on. Now, that's not the limit. It can, of course, go all the way back here to make it have no resistance whatsoever. Next, we're going to do resistors in a series connection. So, first, 10 to 62. So 10, 2, 63, 62, so we're using a reed switch. Oh, looks like we're using a blue again. Now, I've not worked that much with these earlier circuits because I like doing more complex things that take me about 5 minutes. Maybe this will either. Because I like how the fact that the more complex they are, the more greater the reward you get. Like, say you had a very quiet phone and you wanted to play some music from it and you didn't have any speakers but you have this. Then you can just make any of the things that can amplify sound, like 201. Or you can make ship sounds, for example, or other sounds. Anyway, after you've done 10 to 62, we're now doing 62 to 68. So, here to here. I'll see if it's alright, but there's not much chance it is. Oh look, it could be. Maybe if I just extend this. Nope, it's got to be green. After that connection, we are doing 68 to 50. So U to U. That will also be a green. After that, we're doing 49 to 67. There's a lot of greens involved in this one. Now after that one, we're doing 67 to 66. And then after that, we're doing 65 to 61. Then after that, we're doing 61 to 64. Now, you may see here from what I mean by it gets more and more complex, as in we're only on 11 and there's already a lot of connections, but there is even more in the later ones, but not that many more. So after 64, we're doing 63 to 47. Then we're doing 48 to 21. And I think you know what connection we're doing next. 20 to 9. And there we have it. It's all done. So currently it's on. Let me get the magnet. It's on. If I do this one, it's on, but dimmer. This only turns it on and off. I think because of the main switch, it is also slightly on. But at the same time, it's the control switch for everything. So it makes it light up dimly, but at the same time, you do need to do the connections. Next, we shall do resistors in a parallel connection. If you're liking the video, please like and subscribe. I need all the support I can get right now. So, like last time, 10 to 47. Anyone who's getting bored at this, you'll be pleased to know there's only one more to do after this function of the touch plate. I would recommend you have some water nearby. Next, it's 48 to 68. So, 48 to 68. Now from 68 we go to 49. Right, if you're worried about shocking yourself, do not worry, it does not shock you even with the full 6 volts. The only time it will start to shock you is, I believe, at 9 volts and above. So after we've gone to 49, we're doing 50 to 66. Then from 66 to 61. Next, we shall be doing 62 to 64. Then 63 to 47. After 62 to 64, doing 62 to 64. Sorry, we've already done that one. We're doing, so we've done, 63 to 65, not to 47. 63 to 65. Then we're doing 65 to 67. then we're doing 67 to 21. A connection that's all too familiar, because I think we know what's happening after this. A very common 20 to 9. Turn it on. Light's on very dimly. Turn on the push switch, it's on a lot more. Turn on the push switch. Turn on the read switch. For some reason, not on at all. Oh wait, you just have to have the push switch enabled as well. And on to the last one of the day. This one's really simple. 10 to 21. Then 20 to 74. Then 73 to 47. And then 48 to 9. And now it's all connected. Next, grab some water. I conveniently have a water bottle nearby. I'd recommend putting it fairly far away. And then it's flickering. Keep in mind that water makes it very resistant, so you'd be better off trying this using a 6 volts. Yeah, and that looks like it helped, because it's still wet. Now if I disconnect, literally just as bright. Now, turn off this. There you have it. Circuits 1 to 15 completed. Thank you for watching and have a wonderful rest of your day, and please smash that subscribe button and hit the like. Thank you for watching once again.